10 years that Michael Fortune has been designing and building furniture, he's never made anything that he couldn't readily reproduce. This is because virtually all of his machine work is precisely regulated by patterns, jigs, and fixtures. The steps for making the hand mirror he's beginning here are detailed in the accompanying booklet and referenced in the upper left-hand corner of the screen. The process shows how a series of simple jigs can build toward a subtly complex effect, not at all like the homogeneous look we associate with the router. An excavation like this will key the jigs for a series of other operations before finally being fit with a mirror. It's an excellent project from which to learn the principles and quite a few tips for integrated router work.
Hi, my name is Michael Fortune. I'd like to show you some router techniques I use in my work. This recess that I've just finished is the first step in making a hand mirror. On the wall behind me are the rest of the jigs, and over here is the hand mirror. I make this hand mirror in limited edition. There are a number of designs in this series, but I've chosen this one because it best illustrates router techniques in general. The handle is Indian ebony and the head is Brazilian rosewood. When I glued up the head originally in square form, there was a paper joint running down through the center. This allowed the head to separate in two halves so the glass could be installed after all the routing operations had been completed. I've got a sample here that'll illustrate that. This is the paper joint. This cross-section also shows us some of the operations that we'll be performing. This is the cavity that we've already routed. Here's the lip that holds the glass in place, the inside cove, the outside round over, and the offset cove on the back, and also, of course, the recess that holds the handle in place. Let's go on to the next operation. This is a router bit I've made from a bolt. Using my bench grinder, I've ground away most of the bolt head, just leaving the cutting edge. I've taken care to leave adequate back clearance here so that the cutter doesn't generate excessive heat in the cut, and I've also left a little bit of hook here so that it draws the shavings away from the cutting action. The profile that it cuts accommodates the bevel on the mirror. There is one very important point, and that's the diameter of the bolt. It has to be exactly 1/4 inch. Any larger, any smaller, and it'll distort the collet and damage the router. With something else, I haven't found it necessary to temper the bit. I'm taking such a small cut, and I'm using it so infrequently. I'll be using this in conjunction with my router table. I work in a very small shop, so I've had to devise a method of attaching my router table to the back of my workbench. These two battens swing in and hold the router in place. This rubber strap made from a bicycle inner tube is just a little additional insurance. The only other thing we'll be using here is this fence. Let me show you how the whole thing works.
If you adopt this method of attaching the table, make sure it slips into position like this, from right to left, because as you use the router, that's the direction you're most often pushing stock through. You'll notice throughout the tape that Fortune uses some 4 different makes of routers, partly because he's not found one that he's completely happy with, but also, working on several projects at once, it avoids having to continually change bits. These inserts make it possible to suit the table opening to the size of the bit, so that the stock is well supported through the cut. The fence should be positioned just back from the bit shaft, so that the stock rides only on the fence and the cutter protrudes only the 3/32 of an inch necessary to accommodate the mirror's bevel. This plank is a test plank. The grain orientation of the others is advisable, not only for aesthetic reasons, but because quarter sawn wood is more stable and will exert less stress on the mirror. To set the cutter's depth, start with it high, and lower it till the blank just touches the table's surface, then lower it a touch further, so that the clearance for the cutter is about the thickness of tissue paper. Because the fence diameter is slightly smaller than the blank's recess, you can slip the blank past the cutter by keeping the blank tight against the far end of the fence. Take it off in the same way. It's a good idea to check the cut before proceeding. Start on side grain, where the cut will be smoothest. Keep the blank tight against the near side of the fence so the cut will be consistently deep, and rotate the blank smoothly into the cutter clockwise. Note that the fence is keying off the shape cut in step 4. At the end of the cut, shift the blank away from the cutter and carefully remove it. This recess now matches the size and profile of the mirror.
The next operation is to cut the decorative cove around the inside. For that, we'll need a 1/4-inch cove bit. This next operation is very similar to the one we've just completed, with the exception that the fence is slid back slightly to allow the bit to protrude a little bit further into the blank. When it's done, it looks like this. The next operation is to cut the blank round.
These two masonite discs were made using a circle cutter on the drill press. The smaller is a snug fit in the mirror cavity. The larger is the exact diameter of the finished hand mirror head. This is the second time Fortune is using the shape he machined in step 4 to key a jig for the next operation. This is a handy little setup for repeated bandsaw cuts of either regular or irregular shapes. The spacer beneath the finger is slightly thicker than the blank, and the blade is set back inside the finger by the amount of waste you wish to remove. For 1 or 2 hand mirrors, it would have been just as easy to freehand cut the blank a little proud of the line. The setup is shown here because it's a good idea with wide application. Next, to trim this 1/32 inch of waste. Fortune says he's had one accident 10 years ago with the router when using a ball-bearing bit to shape the edge of a disc just like this. The disc grabbed and pulled his finger toward the bit. It was just a nick, but it made clear the importance of using this V-fence when routing circular pieces. The fence is mounted on the same spacer as was used at the bandsaw. Several machines in Fortune's shop have drilled and tapped holes on identical centers so that jigs are interchangeable. The V-fence is adjusted so that the cut will be flush with the pattern. We'll see later on that the accuracy of this outside diameter is just as important as the inside diameter has been for keying subsequent operations. Check the setup before proceeding. Start with the side grain again and rotate the blank into the cutter. This time, because it's an outside diameter, the feed is counterclockwise. Notice how Fortune ensures a smooth surface by retracting the blank from the bit while he repositions his hands, and then overlapping the cut when he recontacts the bit. If tear out occurs, then probably too much waste was left at the bandsaw.
The next 2 operations use the same fence, but only now it's flat on the surface of the router table. The first operation, using this radius bit, will turn the edge here.
The fence has been set so that the bearing of this roundover bit is not quite in contact with the blank. The V-fence provides all the necessary control over the cut. Once again, notice how Fortune withdraws the blank from the bit to reposition his hands, and re-engages the blank, beginning with contact at the left-hand leg of the fence. The face of the head is done, and we can begin shaping the back.
The next operation that we'll be performing is cutting the decorative cove around the back of the hand mirror. I'll be doing this using the 5/8 diameter cove bit in conjunction with this pattern. To establish the depth of cut, I've made this jig. I've chosen to do it this way because with the router bit coming up through the table, we'll be coming up in several steps to this mark. This is a good example of how a standard router bit can be used for decorative effect. I felt that the off-center cove here helped to generate a rather interesting shape as well as focus the transition from the head to the handle.
The amount of offset is a matter of taste. The important thing is that the center line of the pattern be aligned with the center line, that is, the paper joint, of the blank. Thin double-sided tape works better than the thicker carpet tape, and cinching it with a clamp is a must. Notice how the offset pattern sends the bit inside the edge of the stock. The outside waste will be removed momentarily. Now it rides on the fence, which, because it's the same thickness as the pattern, supports the blank from dipping into the bit. Several light passes are preferable over one heavy one, but already we can see the shape we're heading for. The bit is raised. And although we've abbreviated it here, each pass is a full rotation of the stock. Fortune reaches the depth he's looking for in 3 1/8-inch passes. And now, this crescent-shaped outside waist can be removed by shifting the fence forward. Careful here, the cantilever is no longer supported by the fence. It soon becomes a matter of preference whether the rest of the shape is attained through incremental router passes or with a rasp. Don't be confused by the tear out, by the way. Remember, this is only a test piece.
Let's review our progress so far. We've routed the cavity to take the glass. We've cut the recess that holds the glass in place. We've cut the decorative cove on the inside. These first 3 operations, remember, were done with the blank square. Using the cavity as a reference surface, we've then cut the perimeter using the bandsaw and then the router to trim it to its exact diameter. We've then rounded over the outside using the round over bit. On the back, we've just finished cutting the off-center cove here. I'd like you to compare the offsets on these 3 heads. This finished mirror has the smallest offset here. This blank, the offset is small on this side and a little larger here, whereas this blank that we've been working on, the offset is the most severe. I'd like to see the effect this produces. The next operation is cutting the angle that the handle will attach to here. Once again, we'll be using the bandsaw to remove a large portion of waste. Rather than tilt the table on the bandsaw, I've decided to build a jig that tilts the blank. In limited production, this saves time and minimizes possible error. The blank is inclined at 84 degrees here. On the other side of the jig, typically I've included the information that's required to use this jig. This is the cradle that holds the hand mirror head in place. There's sandpaper here to stop the head from rotating as it's passed through the bandsaw.
For the handle to be positioned properly in this inclined surface, the head's paper joint must be perpendicular, aligned with the cradle's center line. Because of the height of this setup, the blade guides cannot be brought very close to the cut. Therefore, proceed slowly, else the blade will deflect.
The next step in the sequence is to route the recess on this bandsaw incline. This technique is similar to the recess we cut on the front of the head. With this exception, to do this I need this template and this collar and bit.
The inclined surface of the head is snugged up against the underside of the pattern. The rest of the jig is a clamp that holds the head tight. Just as with the recess cut earlier to hold the mirror, the first step is to circumscribe the perimeter of the recess. Then, a series of linear passes wastes the interior. This router is usually used for trimming laminates, but it's also ideal for small jobs like this, where a 2.5 horsepower router would be cumbersome. Here you can see the difference, detailed in the booklet, between the pattern and the diameter of the recess it cuts.
Our next operation is to shape the back of the hand mirror head. There's a bit of a fork in the road here. Either we can go in this direction and use hand tools, as I've done on the prototype made several years ago, or I can use a duplicating machine, as I'm currently doing in limited edition. I'd like to show you a bit of both. To start the hand process, I've put a scribe line around the perimeter of the cove here, using this jig from an earlier sequence. On this side, I've hot glued on a softwood round block. This allows me to clamp it in the vise and then rotate it as necessary as I'm carving on it.
This die grinder is most commonly used in the metalworking trades. However, with special bits for wood, it cuts quite efficiently. This is a number 50 random tooth cabinet maker's rasp, a superlative tool for shaping. It doesn't clog easily, and it leaves a relatively smooth surface. There's an element of risk here. One errant stroke can ruin the blank, which, given the amount of work already invested in it, is a serious consideration. On the other hand, you can have a lot of control over a tool like this. The gooseneck scraper removes the tool marks, and the blank can be finished with 220 and 320 grit sandpaper.
And now for the other method. This blank has been prepared to be used on the duplicating machine. You'll notice that there's no offset cove that's been routed around the perimeter here. The duplicating machine is capable of both shaping the surface and generating the offset cove around here. It's mounted in the machine like this. The duplicating machine consists of the frame, the carriage. This slides side to side, back to front, and both motions at the same time. This is the stylus and the pattern, and on this side is the router and the blank. This is the carving bit. It's very similar in nature to a router bit, with the exception that there's no center. This allows it to plunge directly into the material very easily.
Operating this machine is a little like rubbing your belly and patting your head at the same time. For the initial passes, the stylus is held off the pattern so that the cut is not too heavy. The pattern is coated with epoxy and then waxed so that the stylus can move easily over the surface and not damage it. This is a light-duty duplicating machine. Fortune bought it to see how effective it would be in reproducing parts in limited production. He's made a number of alterations to the basic machine so that it will also reproduce chair parts. And he's been happy enough with its performance to figure on investing in a more complex duplicator. The machine is both accurate and fast. When the bulk of the waste has been removed, the stylus is brought into direct contact with the pattern, and long, even passes leave the surface ready for scraping and sanding.
Now that we're finished with the head, we're about to start on the handle. This is the machine blank with which I'll be showing you the operations. This is the handle that's had most of the operations completed. This first jig is a bandsaw jig that establishes this flat plane here.
As indicated in the booklet, the angle of this inclined surface is about 10 degrees. More important is that its length be at least as long as the width of the stock, so that the circular plug that will attach the handle to the head can be cut in it.
This then works in conjunction with this jig on the drill press with a fly cutter to cut the end of the handle that fits in the recess on the back of the head.
The fly cutter is an inexpensive tool. Fortune has set this one permanently to the correct dimension, and it's now part of his production paraphernalia for making hand mirrors. This is much more efficient than remeasuring each time the handle components are made.
We go from here to a combination of bandsaw and router jig, very similar to what we've already done on the head. The difference here is that we'll be using a flush trimming bit.
Fortune could have used a finger fence here, as he did with the head, but for small runs, and because the cuts are mainly straight lines, sawing freehand works fine. Ideally, ball bearing guides do not rotate with the bit. In reality, as you can see here, there are always some of those 26,000 RPMs that get transferred. That's why the pattern in this setup, which has wide application, is 5-ply Baltic birch. It resists the pummeling better than masonite. Tempered masonite patterns have been fine for the previous operations because they rode against stationary collars or fences.
With that completed, this next jig cuts this surface under here.
Notice that this jig not only positions the blank for the taper cut, but it also supports it so that the center line for the handle is parallel to the table. Failing to do this in this operation would create the wrong taper and cause problems later on.
With the platform in place, it'll cut this angle for us here.
This cut demonstrates nicely the importance of positioning the blank properly for a taper cut. If the handle end were left to rest on the table, a crooked end angle would result. The waist where the handle pattern was screwed down is removed by simply sawing in the kerf left by the fly cutter.
This circle template helps shape the underside of the handle here so that we can complete the rest of the handle with files and cabinet scrapers.
That masonite template is used merely to pencil a circle on the angled end of the handle as a guide to shape to. This is a number 48 cabinet maker's rasp, and the dust mask is important when working with most exotic hardwoods. This ebony shapes very nicely.
Or we can go in this direction and mount the handle on this jig and then put this in the duplicating machine.
Once again, Fortune holds the guide off the pattern so that the initial cuts are not too heavy.
Before the handle is put in place, both the head and the handle are finished sanded. The head is then separated down the paper joint and the glass is installed. The handle may require a little hand fitting here, and then it's epoxied in place. In closing, I'd like to show you some of the other designs in the series. This is the first design, made several years ago. The shape on the back evolved from sketches from a ginkgo leaf. This is very similar to how the ginkgo leaf attaches to the tree. After making a number of them, I decided they were just too labor-intensive, particularly this intersection in here. With that in mind, I decided to continue my sketching and came up with this variation where I've separated the head from the handle. The rudder became very useful for joining here as well as the other details. This detail also evolved from the intersection between the leaf and the stem. This is the most recent variation. Using the bandsaw, I've segmented the head into a series of pie shapes and then delineated them with small inlays of ebony. The handle is an oval, and by cutting it at a very specific angle, I've ended up with a circle, and this relates back to the head as well as the other end of the handle. The ebony carries through to this side as well. Hopefully, not only have I shown you how the jigs work with the router, but how they work with one another to complete this object.